Good day and thank you for joining us. If you can remember from last week, what we did was we went over some questions from the June 2018 paper. And this week we will be continuing doing that with another 2 questions this week, okay? So let's just get straight into it and move over to the paper. So you can see here we have question 1, okay? So this is from the June 2018 paper from SP. So what you guys are going to do is you're going to pause the video now if you are on YouTube or whatever other platform, and you're going to attempt doing these questions right now. Once you are done, you can resume the video and I will be doing the solutions for them straight after that. Thank you very much. Okay, so you should be finished now. So what I'm going to do is I'm going to do the solutions for these questions. So we can see in question 1.1 that it say determine the HCF, the highest common factor of 72, 96 and 120 using prime factorization. Okay, so I'm just gonna get onto my page over here so I can do the solutions. So we can see that in the first one they want us to find the HCF of all 3 numbers. So what we're going to do is we're going to do a ladder for each one of these numbers. Okay, the ladder method. You know the ladder method, remember? So let me just do this. We have a nice ladder going down, okay? And then we're also doing it for 96. Have a nice ladder going down. And then we're doing it for 120. Cool. So we know how the ladder works. We're going to use the lowest prime factor that we can, which is going to be 2, right? And what we can do is divide 72 by 2. So first we get 36. Now again we can use 2. So we get now 18. 2 again. We get 9. We see we can't use 2 again because 2 can't go into 9. So we use the next lowest prime factor, which is going to be 3. And we get 3 until we get down to 1 as our final number. And that would be that ladder complete. So now we move on to here. Same process. Right, so 2 still managing to go into all of these, okay? So now we have to move on to 3, remember, because 2 can't go into 3. And then our ladder finishes off with 1 again. Two can't go into 15, so we move on to 3, because 3 can go in and we'll get 5. Now 3 can't go into 5, so we have to use the 5 next, and then we get to 1. So that's our ladders complete. So what we're going to do now is write out each one of these ladders as a sum, okay? So we know 72 is equal to, so now we're going to put the prime factors there. So 72 is equal to 2 times 2 times 2 times 3 times 3. Cool. We also know 96 is equal to 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 twos, and then a 3, okay? And then we also know that 120 is equal to 2 times 2 times 2 times 3 times 5, cool? So once we get to this point, we need to look at grouping numbers that are the same throughout each sum, okay? So basically what we're going to do is, so we have 2 over here, we have 2 in all 3 sums. So we're going to surround it or circle it like this. We can see we have 2 here in all 3 sums again. Once again over here. And then we can see that the sum just become different over here, and the last thing that we can actually find in common is this 3 over here. So it's going to look a bit weird how it's going, but this is when we surround all of them. Okay. So we have a 2, a 2, a 2, and a 3. So we know when we're working at HCF, we're only going to be timesing the numbers that are circled. And each number that is circled is going to count as one number. So these 3 numbers are only going to represent 1, 2. So basically in the calculation of working out HCF, it's going to be 2 for the first one, times 2 for the second one, times 2 for the third one, and times 3 for the fourth one, because remember we counting the number that is circled, right, as one number. So we have 2 times 2 times 2 times 3, and eventually we get to our final answer of 24 being our HCF. Okay, so our HCF here is 24. So we did the ladder method as usual. We put out the factors into a sum, and we circled the common factors between each one of these, and we times them to get the highest common factor. Okay, so that's 1.1 complete. Let's have a look at the next question. Was 1.2. Determine the cube root of 1728 using prime factors. Okay, so moving back over to my sheet, we're going to be doing 1.2 now, and they want us to find the cube root of 1728 using prime factors. So how do we get our prime factors for this number? We have to use the ladder method. Okay, so that's the first thing we're going to do, is the ladder method to find the prime factors. So 1728, so now we can divide it by 2, and we're going to get 864. We divide by 2 again. Sorry, my bad. It's going to be 432. We can divide by 2 again. Okay, so we can see now that 2 can't go into 27, so we try 3, because we know that 9 goes into 27 3 times. We just carry on with the ladder. Use 3 again, we get 3. 3 again, we get 1. Okay, so we know that the sum for 1728 is equal to 2 times 2 times 2 times 2. So it's 1, 2, 3, 4, 5, 6. So another over there, and then 3 3s. So once we get to this point, we can write it in a simpler form, obviously, of 2 to the power of 6, because there are 6 2's, right? So it's basically 2 to the power of 6, and that times 3 to the power of 3. So we know that this is equal to 1728. So which means because this is equal to 1728, we can put it underneath the cube root. So we can put underneath the cube root 2 to the power of 6, 3 to the power of 3. So once we do that, we can then work it out. So we know that with laws of exponents, if we're trying to square or cube root any exponent, okay, we would divide the exponent, okay, by the number on the outside. So what's going to happen here is we're going to be left with 2 to the power of 6 divided by 3 gives me 2 times 3 to the power of 3. 3 divided by 3 gives me 1. So we have 3 to the power of 1. So we left with 4 times 3, which is going to give me a final answer of 12. Because the 2 square gave me that 4, okay? So then we did 4 times 3 equals 12. So therefore we found the cube root of 1728. Cool? So that would be our final answer there. Moving on to the next question. They ask us, use the rule of divisibility to determine if 776 is divisible by 4. Okay? So we're using 776. So we know for the rule of divisibility of 4, the last 2 digits of the number, right, they have to be divisible by 4. So 4 has to be able to go into the number that the last 2 digits make. So we know the last 2 digits make 76, okay? So 76 divided by 4 is going to give me 19. Therefore, 76 is divisible by 4. and therefore 776 is divisible by 4 as well. Cool. So we move on to the next question. So we're on question 1.4 now, which has 3 different sums in it. So it just says for us to simplify these ones, okay? So 1.4.1, we were given square root of 64 times 4 times 36. Now in this situation, what we can do is split it up to 64, square root of 64 times square root of 4 times square root of 36. That times sign over there allows us to split it up like this, okay? So once it's split up, we can do it separately. Square root of 64 gives me 8 times square root of 4 gives me 2 times square root of 36, which gives me 6. Once we times all of those together, we get a final answer of 96. Cool, so that's that example simplified. Then we move on to the next one, 1.4.2. 1.4.2 asks us to find the square root of 5 squared plus 12 squared. So what's different here is that there's a plus sign, so we can't just split it up and then decide to do square rooting separately, okay? So we have to work out what's underneath the square root first because of this plus sign. So if we're doing that, we're going to get 5 squared gives me 25 plus 12 squared gives me 144, which gives me the square root of 169, and the final answer will be the square root of 169 is 13. Which is our final answer for 1.4.2. Hopefully that makes sense. And then moving on to our last one, which is going to be 1.4.3. They ask us here to do 3 over 4 divided by 5 over 8 plus 2 over 3. Cool. So what we're going to do is we're going to deal with this division first, okay? Because if you look at your BODMAS or BEDMAS, you know that you must do division and multiplication before any addition can happen, okay? So what's going to happen is we're going to do 3 over 4. So we're going to put it in brackets because we're going to be doing it first. So with division in this case, we know we flip and times. So we can change the times by flipping 5 and 8. So it's 8 over 5 now plus 2 over 3. Okay, so the flip and times it will apply here. Once we do that, we get a final answer of, so we do 3 times 8, or actually, let's just simplify it first. We know that we can cross simplify. So let's look at this. 4 can go into itself once, 4 can go into 8 2 times. Cool. So once we do that, we get 3 times 2, which gives me 6 over 1 times 5, which is 5. So we have 6 over 5 plus 2 over 3. Cool. So what we did here, we simplified the fractions first because we could do a cross simplification. We knew that 4 went into itself once and went into 8 twice. And remember, this cross simplification can only go up and down and across. It can't go straight across like that. That is not allowed. Cool. So now it's just a basic addition of fractions. So lowest common denominator here is going to be 15. That's between 5 and 3. So then what we do is we say 15 divided by 5 gives me 3 times 6 gives me 18. We do the same with this fraction on the right hand side. We do 15 divided by 3 gives me 5. 5 times 2 gives me 10. So once we get that, we can just add it up. We get 28 over 15, which we then turn into a mixed number, which comes out to 1 and 13 over 15. And that is its simplest form. That is the solution for question 1, guys. So moving back over to the question paper, we're going to be skipping question 2 today. And we can see we did question 4 and 5 last week. And this week we'll be doing question 6, okay? So I'm going to have to zoom out to be able to fit it all in one screen, but hopefully you guys can make out what is on the screen. So this is question 6. It says determine the values of the angles x with reason. So once again, if you're watching on YouTube or on every other platform, I need you guys to pause the video here, do the solutions. Once you're done with solutions, you can play the video again, and I'll be doing the solutions with you guys after that. Thank you. Okay, so you should have finished with the examples by now. So what we're looking at here is a right angle triangle, right? That is confirmed by this square over here, right? So knowing that, what do we know about the right angle triangle? Sorry, not the right angle triangle. It is a right angle. What do we know about the right angle? A right angle angles add up to 90 degrees, okay? So this angle over here is 90 degrees. Therefore, they've given us one angle here, which is 37 degrees, and they've asked us to find out angle x. So, because we know that a right angle is equal to 90 degrees, we can simply just go ahead and do this, okay? So I'm just going to get rid of this. So we can say here by 6.1, x plus 37 degrees is equal to 90 degrees. That's because x and 37 are in this right angle, which add up to 90 degrees, right? So that's our statement. We need to give a reason as well. And the reason that we're going to give is complementary angles, okay? And that is because, let me just go back to our diagram over here. We can see that AB is perpendicular to BC. That's given to us, okay? So we can say AB is perpendicular to BC. Cool. So now we can go ahead and work out the value of x. So we say x is equal to 90 degrees minus 37 degrees, which is going to give me a final answer of 53 degrees for 6.1. Now we can move over to 6.2. Let's go back to our question paper. We can see here that this is a straight line. The line AC is a straight line, and the line BD is cutting into this line to make two angles, okay? So what do we know about a straight line? We know a straight line adds up to 180 degrees. Cool. So they've given us 81 degrees over here, and they've given us 3x as that other angle. So we know that 3x and 81 degrees must add up to 180 degrees. So how we're going to write that is like this. So we'll say 3x plus 81 degrees is equal to 180 degrees, sorry. So that's our statement. So these angles on the straight line must equal 180 degrees. That's our statement. Now we give our reason, which is angles on a straight line. Cool. Or supplementary angles. Okay, just supplementary angles on a straight line. Cool. So that's our reason. You can use either one of these. And now that we've done that, we can work it out. So we get 3x is equal to 180 degrees minus 81 degrees. So 3x is equal to 99 degrees. Now we have to get x by itself. So we divide both sides by 3. 3's cancel each other out over there. We get x is equal to 33 degrees for our answer for 6.2. So now we're going to move on to the next one. So we can see here that we've been given this triangle, right, with another line that is coming out of it, okay? So the way we're going to solve this is, obviously we have x here in the triangle and 55 here in the 55 degrees here in the triangle. We know that all angles of a triangle will add up to 180 degrees, okay? And we can also see here that there's 120 degrees outside. So if we look at CD over here, what can we tell about CD? That it's a straight line, okay? which means that it adds up to 180 degrees, which means we are just missing one angle here, which we can call B2, okay? So we'll call that angle B2 over there. So what's going to happen is we're going to say, we just clear this up. We're on 6.3. So we can say angle B2 plus 120 degrees equals 180 degrees. Reason, angles on a straight line. Cool. Solve for B2 now. Get 180 degrees minus 120 degrees. Angle B2 is equal to 60 degrees. So now we found out the value of one of the angles. So now we can see that we have at least a term for each angle in triangle. So we have 60 over here, which we worked out. We have 55 and we have x. So now we can just do a final calculation. So now we can just say x plus 55 degrees plus 60 degrees, which we just worked out, is equal to 180 degrees. Angles of a triangle equal 180 degrees. Cool. So now we just work out x. We say x is equal to 180 degrees minus 60 degrees minus 55 degrees. And this gives us a final answer of x is equal to 65 degrees. Cool. So this is just one way we can work it out. There is also another theorem that we can use. So if you can see, we have 120 degrees as an exterior angle of this triangle, right? And if you look inside the triangle on the opposite side of the triangle, we have 55 and we have x, right? You can see 120 is on this side of the triangle, 55 and x is on the opposite side of the triangle. Now there is a rule that says that this exterior angle over here is equal to the sum of the opposite interior angles of the triangle. So how we're going to write that down is like this, okay? We're going to say the exterior angle, which was equal to 120 degrees, right? It's equal to the sum of the opposite interior angles, which are x, sorry, not degrees, x and 55 degrees, right? So exterior angle of the triangle is equal to opposite interior angles, the sum of the opposite interior angles. So we write that reason out. Exterior angle of triangle is equal to the sum of opposite interior angles. So I'm just showing you guys another way that you could have worked it out. Obviously this way is the least complicated, but this way that I'm showing you now is the shortest way. Okay, so now we can work out for x, 120 degrees minus 55 degrees, which straight away just gives us our 65 degrees, which we worked out in the previous in the previous method. So that is the two ways to do 6.3. So now that we're done with 6.3, we can move on to 6.4. So 6.4 over here, we get given this triangle over here, and they want us to work out x over there. So the way that I see that we can do this is we can say that we can work out this angle B over here, right? So we can work out that angle B because we have two known angles of this triangle, so we can work out the unknown angle. So let's do that first and then see what we can do from there. So we get given 55 degrees and 75 degrees. So 55 degrees plus 75 degrees plus, we call it angle B, is equal to 180 degrees. Our reason, sum of angles of triangle equal 180 degrees. So now we work out for B. We say 180 degrees minus 75 degrees minus 55 degrees. And that gives us a final answer of 50 degrees. So angle B is equal to 50 degrees. So we've worked out angle B now. So we go back here, and now we need to work out x. So if you haven't noticed already, these lines that are coming out of the triangle, they are forming a specific shape over here. What shape is inside of the square right now? We can see a x, right? So what is the rule that applies to an x? The rule would be vertically opposite angles, okay? And what do we know about vertically opposite angles? That they are equal. So therefore we can just say that x now is equal to 50 degrees. And the reason is vertically opposite angles. And just like that, we've finished the solutions of question 6. So thank you very much for joining us today. I really hope that today's session helped and that we could finish off this paper now. It's really great. Please just tune in to us next time with our next video. Thank you very much.